Hello guys, welcome back to the MACM 101 Discrete Mathematics Tutorial 7. This week, we will start a new topic, function. I'm not sure if you watched the lecture video already, but I think you have learned a function operation in high school. This week, we help you recall some concepts and introduce some new stuff. After you grasp the content of the function, you should take some practice. Please try to solve the problem set by yourself first, and watch this detailed tutorial video. Let's have a look at the first question together. Determine whether or not the following relations are functions. If a relation is a function, find its range. So for the first relation, we have an order pair x, y, both x and y belongs to integers. And we have y equals to x squared plus 7. And it says this relation from integer to integer. So when you ask to predicate if a relation is a function, you have to know the definition of function. So by the definition of function, each input has a single output. So for each x belongs to integer, there is a unique y belongs to integer such that y equals to x squared plus 7, right? So this relation should be a function. Why? Because so whatever value you choose for the x from an integer set, you get a unique y that maps to y equals to x squared plus 7 in the integer set. So this relation is a function. This relation is a function. So the next one is if the relation is a function, then find its range. So we have to find the range of the function. We know that the this one is the domain and this one is a codomain. So you have to find the values in the codomain that restrict to make the equation valid. So let me try some value. Let x is to 1, 2, 3 or something. We got y equals to 1 squared plus 7 equals to 8. 2 to the square plus 7 could be 11. 3 should be 16, right? So we have the range as 8, 11, 16, something, blah, blah, blah. So we know the range is just for x belongs to integer, we have x squared plus 7. This is a range for this relation, or for this function. And the second one, the question B, we have a order pair xy, and both x and y belongs to real number. We have y squared equals to x, and this relation is from real number to real number. Okay, so by definition, a function for any value in the domain, it has exactly one associated value in the range, or we say it's one value from the first component of the order pair. It's associated with exactly one value from the set of second component of the order pair, right? So this relation is not a function. Why? Because for every y not equals to 0, we have something like negative y squared equals to y squared, right? Which implies y squared, y, and y squared negative y. Both side belongs to real number. But we know that y is not equals to negative y. So for any value in the domain, it has two values in the codomain. So this relation cannot be a function because it's not meeting the requirement of the function. So that's the first question. Let's move on to the question 2. For each of the following functions, determine whether it is one-to-one and determine its range. A function is a one-to-one if no two different elements in the domain has the same elements in the range, which means if we have fa equals to fb, then a equals to b. Or we say if a not equals to b, then fa not equal to fb, right? To make it clearly, I will draw a diagram. So we have, consider this one is the domain and this is a codomain or range something. We have like -3, -1, 0, 1, 5, 0, 1, 2, 3, 4. One-to-one means each value in the domain has a associated value in the range. This means the one-to-one. And we can have something like 4, 5 here. We can have some value in the range that not maps to the value in the domain, but any value in the domain should have the associated value in the range. So let's have a look at the question. What's a? So for the function a, we have f from integer to integer. We have fx equals to 2x plus 1. If we have a b plus 2 integer, if fa equals to fb, which implies 2a plus 1 equals 2b plus 1, and a plus 2b, then the function is one-to-one, right? So we see here, we know a must equal to b, right? So this function is one-to-one, and the range should be x belongs to integer and 2x plus 1, which is all odd number, right? All odd number. I mean they are integers. That's the function a. Then the function b is maps from the rational number to rational number, and fx equals 2x plus 1. Similar applies to the rational number. So for a b belongs to rational number here, fa equals to a plus 1, fb equals to b plus 1, and we got v equals to b here, and hence it's one-to-one, right? This function is one-to-one. Since for any value in the domain, we can find a value in the range. So I mean for any value in the rational number set, we can have a value 2x plus 1 in a rational number set. The range should be the same. X belongs to rational number and 2x plus 1. So it's all rational numbers. Yeah, that's the function B. Next one should be function C. We have the function maps from integer to integer, and fx equals to x cubed minus x. So I think this function is not one-to-one. Why? Because if we assign x equals to 1 and x equals to 0, both the output from function should be 0, right? Let me write down f1 equals to 0 and f0 equals to 0, right? We have x cubed minus x. So f1 just 1 minus 1 equals to 0. f0 is 0 minus 0 is 0. So we have f1 equals to f0. So this function is not one-to-one. This function is not one-to-one, right? Because if the function is one-to-one, we have no two different elements in the domain has the same element in the range. But in this case, we have f1 equals to f0. So fa equals to fb, but a equals to b, and a does not equals to b, but fa equals to fb. Yeah. So the function is not one-to-one function. And let me find the range. So the range should be x belongs to integer and x cubed minus x. This should be the point on the curve. Points on the curve x cubed minus x, right? Because x belongs to integer and y belongs to integer as well. So we have the curve like this, and that will be the point on this curve, right? That's the question 2. Here, question 3, we have let f maps from A to B, where A equals to x union y, with the set x intersects with y equals to empty set. Here we have two restrictions, and the fx and fi are one-to-one. Does it follow that f is one-to-one? So what's the restriction? Say that if the function if the function f maps from A to B, be a function, and the set x is a subset of A. So we have here f mapped from A to B, and x is a subset of A. Then the restriction f, x could be x maps to B. Let's call it a restriction of f of c. Of x if fx a equals to fa for all a belongs to x. Same applies to the fy. We have something like y is subset of a, y y maps to b. We have the restriction of f of y. If fy a equals to fa for all a belongs to y, right? So we can construct a set for x and y, and therefore the a and b, to prove that the function f is not one-to-one. So how can we do that? That x equals to 1, and they said that only have the element of 1, and y a set of 2. Then we have a equals to x union y equals to 1, 2, and that b equals to 2, say 2, right? And here we can verify that x intersects y is empty side. So then we have f, the range of f should be 1, 2, and the order pair 2, 2, right? Because we have 1 and 1 must be, and 2 must be. We have 1, 2, and 2, 2 here. We can see that f is not one-to-one, since we have f1 equals to f2 equals to 2, right? As we know, the if a function is one-to-one, which means no two different elements in domain has the same element in range, whereby we have f1 equals to f2 equals 2. So the function is not one-to-one. So when you ask to disprove a function or something, just use the logic that we have learned in the previous lectures. Say the propositional logic. You can raise any counterexample to disprove the statement. That's it, question 3. Question 4. For each of the following functions, f that maps from the integer to integer, determine whether the function is on 2. If the function is not on 2, determine the range of y. So by the definition of on 2, for any value in the range, you can find a value in the domain that maps to the value in the range. It's different from the one-to-one, right? So one-to-one means no two different elements in the range in the domain can find the same value in the range. But the on 2 means if you pick any value in the range, you can find a value in the domain that maps to the value in the range. So let's have a look at the first function. So the first function is fx equals to 2x minus 3. So in this one on 2 function, so let's check that. If you choose if choose a y belongs to integer such that y equals to 2x minus 3, then we solve for y. We get then we solve for x, because we want to find the associated value for the value y in the range. So we want to find the associated value in the domain for the value in the range. So we have to solve for x. We got y plus 3 divided by 2. We have this equation. So does this equation belong to the integer? We say not, right? Because if we pick if y is an even number, then the relation does not hold. So if y is an even number, then the relation or equation doesn't hold. So the first the first function is not onto function. Very simple that. So the range of the function is all odd number, right? Because if we have y plus 3 divided by 2, if we want this equation to be violated, we have set all value of y to be even number. Then the equation holds. So the range should be all odd number. And the function b here, we have f(x) equals to x squared plus x. Suppose that exists y belongs to integer such that y equals to x squared plus x. Then we can rewrite the function here as x plus 1/2 square minus 1/4, right? And as we know, this function, this part can only greater or equal to 0, right? So the whole function must be greater than or equals to minus 1/4. So f(x) must be greater than or equals to negative 1/4. So for all y less than negative 1/4, there does not exist y such that f(x) equals to y. Hence, it's not onto function. Right, it's not onto. So what's the range? We have here all y must to greater than equals to negative 1/4. So we have the range y belongs to integer y greater than equals to negative 1/4. Yep, that's the question 4. In the first half, we have talked about the fundamental concept of a function. So you should learn what is a function and how to predicate whether a relation is a function. We also talk about the one-to-one function and the onto function. The second half of this problem set will all about the composition functions. So what is a composition function? Let g be a function from a to b, and let f be a function from b to c. The composition function f and g should be something as f composite g. It's a function from a to c, defined by f composite g a equals to f g a. And so we have like g maps from a to b, and f maps from b to c. Then the composition function f composite g is from a to c. So in the question 5, it says let f g both map from the real number to real number, where gx equals to 1 minus x plus x squared, and fx equals to ax plus b. And it says if g composite f, x equals to 9x squared minus 9x plus 3, determine the coefficient A and B. So what do we have here? We have gx equals to 1 minus x plus x squared, and fx equals to ax plus b. So we want to combine these two functions and make a compensation function. So we have g composite fx equals to 1 minus ax plus b plus ax plus b squared. Right. So how do we get this? We treat the fx as a whole part and plug into the gx. So we have this equation here. Then we expand the equation. We have 1 minus ax minus b plus a squared x squared plus b squared plus 2axb, 2abx. We always to put the variable at the end. So we have 1 minus b plus b squared plus 2ab minus ax plus a squared x squared. And we also have g composite f x equals to 9x squared minus 9x plus 3. So by comparing the coefficient in these two equations, we can have 3 equations. We have a squared equals to 9, and 2b minus 1a equals to negative 9, and 1 minus b plus b squared equals to 3. The first equation here implies a equals to positive and negative 3. And the third equation here implies b equals to negative 1 or b equals to 2. So then we have 4 combinations. We have 4 ordered pair, 3, negative 1, 3, 2, negative 3, negative 1, and the negative 3, 2. So we have to verify which order pair can make the compensation function to be violated. We can use the equation 2 to verify that. So if we plug the a equals to 3, b equals to negative 1, we got the 2b minus 1 times a equals to negative 9. So this one is valid. And we also know that this one is valid. So why this one is not valid? So if we have 2 times 2 minus 1 times 3 will be 9. It's not negative 9. So the only valid pair should be positive 3, negative 1, and the negative 3, 2. So here's A, B. Let's move on to the question 6. Let G maps from natural number to natural number be defined by Gn equals to 2n. If the set A equals to the set that have the element 1, 2, 3, 4, and F maps from A to n to a natural number, is given by F equals to 4 order pair 1, 2, 2, 3, 3, 5, and 4, 7. Find the composition function G composite F. So we have F here, F equals to 1, 2, 2, 3, 3, 5, 4, 7. We have 4 order pair. So the image of A should be something like F1 equals 2, F2 equals 3, and F3 equals 5, and F4 equals to 7. Then we can construct a set B. We have B equals to 2, 3, 5, 7. Right, because 2, 3, 5, 7 is the range for the function f. Then and we know that gm equals to 2n. So we have g2 equals to 4 and g3 equals to 6, g5 equals to 10, and g7 equals to 14, right? 2, 4, 6, 10, 14. So then we got g constant f, the x equals to 4 ordered pair, because we have 4, 6, 10, 14 here is gx, and we have the x here 1, 2, 3, 4. Then the 4 ordered pair should be 1, 4, 2, 6, 3, 10, and 4, 14. That's the range of the G composite F. Question 7. It asks you that if the composition function f circle G is onto, does it follow that G is onto? So suppose that we have a function G here, G maps from A to B, and we have a function f of maps from B to C. Then we have the composition function f composite G maps from A to C. And it says the composition function f circle G is onto. What does that mean? That means every element C in the codomain C, there exists at least one element A in the domain A such that f composite G A equals to C. Let me write that down. So for all C belongs to the codomain C, exists A belongs to A such that f composite G A equals to C. So to make it clearly, I will draw a diagram here. So we have some element in the set. Here is a set A, B, and C. So we can have some mappings here. We have A maps to A, one maps to 1, 2, 2, 3, 3, and 1 maps to 1 here, 2 maps to 2, 3 maps to 3. And we have, we have G here, we have F here. So if the composition function f circle G is the onto function, that means for any value in the codomain C, we can find a corresponding value in the domain A here, right? But if we have a look at this part, for the function G maps from A to B, here we can find a element 4 that in the codomain B, there does not have any associated value in the domain A that maps to the element 4. So what does that mean? By the definition of onto function, if there exists an element in the codomain, if it does not has if that does not have any element, I mean the associated value in a domain that maps the value in the codomain, then the function is not a onto function. So the function g is not an onto function because we have a value here that has no associated value in the domain maps to that. So the function g is not necessarily an onto function. Yeah. Although the composition function f composite g is the onto function, but g is not necessarily an onto function. In the question 8, we talk something called inverse function. First, if you want to find an inverse of a function, you have to check if the function is one-to-one first. So, and the question 8 asks you, for each of the following functions, f maps from real number to real number, determine whether f is invertible, and if so, determine the inverse of function f. And in the first function, f equals to the order pair x, y, to x plus 3y equals to 7. Is this function a one-to-one function? This one is one-to-one, right? Because if we have fa equals to fb, then a must equals to b, right? So this function is one-to-one. And what's the inverse function? So if f equals to x, y, such that y equals to mx plus b, then f is invertible, and f, the inverse of function f should be x, y, x equals to my plus b. So let's have a look at the first function. Since we have checked the first function is one-to-one, so we want to invert find the inverse of the function. We have f equals to xy to x plus 3y equals to 7. So we have xy, y equals to negative 2 over 3x plus 7 over 3. So how to find the inverse function of the original function? So we just interchange the value of x and y, then solve for y. So what do we have here? We have y equals to negative 2 over 3x plus 7 over 3. Then we interchange the value of x, y. We got x equals to negative 2 over 3y plus 7 over 3. So then solve for y. We have x equals to negative y plus 7 over 3. We got y equals to negative 3 over 2x plus 7 over 2. So the inverse function should be x, y, that y equals to negative 3 over 2x plus 7 over 2. This is the inverse function. So the next one, function b. So similarly, we have to check if the function is one-to-one function. So is this function in one-to-one function? It's not, right? Why? Because if we can find some value fa equals to fb, but a does not equals to b, then the function is not one-to-one. So here we have something like f0 equals to f1 equals to, sorry, f negative 1 equals to 0. Yeah, negative 1. Right? So we have y1 equals to 0 plus 0 equals to 0, and y2 equals to negative plus negative 1 equals to 0. But we have x1 not equals to x2. So this function is not one-to-one. So if the function is not one-to-one, then the function is not invertible. So if the function is not invertible, we can not find its inverse function. So f is not invertible. That's all the practice question for the topic function until now. At this point, we don't introduce too much, just some fundamental concept about function. But you should understand that function is an important concept in a lot of scientific field, not just in mathematics. You will see a lot of function in the future, so take it serious. I think that's all for this tutorial. Thank you.